Welcome to the Boulevard of Broken Dreams. The Padauk Programmer has, well, it's eaten my life away, and it's been quite the journey. And I've got sort of quite a few of these now that don't work. In fact, sadly, I've got more that don't work than do work. These are the ones that I've been able to dig out. And the reason I have dug them out again is, well, originally I didn't throw them away because I thought maybe if I swap out a couple of things on this old man version or on this semi-legit version, I'd be able to maybe make a working program. But all of these were soldered up by hand, and I've since found that actually baking them in an oven works best. So I'll put a link up so you can have a look at the successful ones. In the meantime, something weird has happened to the microcontroller market, or the semiconductor market, I guess you could say, and all of these ICs, which came into Tassie at about, I don't know, $1 each or under, now, seriously, if you can get them, they can be upwards to $20 each. So I don't know how many that I've broken or fried along the way, but I thought it might be useful to desolder these ones anyway. So there's 7 chips right there. So thinking about it, like that could be well over $100 worth of STM32s, and then maybe use the oven to make up some new ones, hopefully. And just for fun, I've swapped in an SSD drive on my computer, which seems to have broken the way that my computer now talks to these guys anyway. So even the legitimate ones, I can't get any sense out of. So yeah, what a project! It just keeps giving. Anyway, let's get to desoldering, and that's the start of maybe making some recovery. Perhaps not on the free PDK programmer for the Padouks, but at least maybe to recover these for other projects.
So let the desoldering begin. There's a little break there, and I've brought in my apprentice Kelly to keep an eye on me because the camera fell down and yeah, disturbed the whole process. But in the end, once up and running, the desoldering is pretty straightforward with the old hot air gun, and we are able to end up with all of those successfully desoldered. The next question is, can we reuse them?
So when does a hobby become an obsession? No, I'm not sure. This is another variation of the Padauk Programmer, and this is one designed by Tim, which I'll link his details both on the blog and also in the description below. But he designed what he calls the light version, and this is revision 1. There's a few components that have changed or are missing from the original Padauk Programmer. And in fact, Tim was very kind to send one to me when I was at the height of my frustration with my own version of the programs. And for a while, it was the only one that I had that worked. So that's quite amazing. So thank you so much for that, Tim. And in the meantime, I went on to eventually use an oven to make my own version from the original free PDK version of the programmer. But I've also just recently ordered this light version from Tim's design. Now, Tim has shrunk down the components even more, which you'd think would be a terrible thing. But in fact, what it's allowed him to do is to be able to choose manufacturers that can pre-populate their boards with these SMD components, which they have here. So the only thing that I would need now is the STM32. This one here is the op amp. This is a through-hole version of the oscillator and a button. That's SMD. But it was interesting enough that some of these components, like these three here, although you know, as originally designed, you could have them as part of the pick and place manufacturing process. This guy here, for instance, is basically not available. And I did have a lot of these and they're easy to solder, so that was fine. But for some reason also the SMD buttons were not available. But anyway, so what I need to do is to put those on with some female headers and some male headers, and theoretically I'll have a working version.
Right, so a little bit of flux and the old STM32s recovered from those old board goes onto the new board, the revision 1 of Tim's Padauk Programmer Lite, and then the op amp and switch and the actual crystal itself, the 8 megahertz crystal. Then some female headers and we're good to go. And what a thing of beauty it is too. But the question is, will it work?
Board on the left-hand side works. Board on the right-hand side does not work. Things that I've tried include swapping out the STM32 3 times. That's the third version there. The op amp, I think that's the third version as well. And still no joy. So I'm looking around thinking, what else could be wrong? And it struck me that these two were different. And so I did a test on this one, and in fact, the button is not firing the whole time, which means the STM32 doesn't go into programming mode, which means you can't actually put on the firmware that's required before you even start the process of programming other chips. So I'm going to swap the button out and see if that works. It's crazy, but it might just be the secret. So lots of twists and turns along the way, but in the end we've got 5 working Padauk programmers, all with reclaimed STM32s from, for instance, this original guy, failure, and this old man version also failure. So yeah, worth desoldering the chips and repurposing. So that's a great result. And just to show that it works, I've got a PFS 154 in the back here doing traffic light duties. So traffic light shows that it's red at the moment, and we go to green and back to red on demand. So that's the circuit working. That's 5 circuits working. We might do a bit more exploration of this traffic light actually. I quite like that, the idea of changing a traffic light when you need to. Anyway, see you next time.